Okay, so moving on to day 6. All right, let's bring it up. We had day 5 in the last video. What we did was created a list of points, a list of the C value points, right, for every frequency value up here. So what we're going to do next is come down to the algebra window, and in the input, we're going to type in L sub 6, L subscript 6 equals. Now, what we're going to do is find the absolute value of each point, A, B, S. What that basically does is it finds the distance from the origin. That's all it is. It's like it's the radius from the origin to that red point. How long is that radius? So the absolute value applied to a point is a length from the origin. That's all. So, you know, it's like doing the Pythagorean theorem with these two x and y values, square rooting, you get 0.9 and so on. Okay. And what we want to do is try to somehow get a graphical representation of all of these absolute values. Okay. You can think of these as the magnitudes of each center of mass point. So what we're going to do, I'm going to hide this there. Come over to view, and we're going to open up a different window called graphics 2. I opened it up over here. There's a pull. Okay, if we pull this down, I'm going to bring it down to the bottom. Okay, so I have it separated. That way I can see what I was doing over here, and then separately I can see a different graph down here. Okay, and what we want to type in to the input field now is a command called bar chart. It's a bar graph basically, okay, but it's called bar chart in Geogebra. Parentheses 0, comma, n minus 1, comma, L subscript 6. There, it popped right up there, right? This is a bar graph of every point in list 6. Except it goes way off the screen. We can easily fix that by, if you click this Move Graphics View button, go down to the x-axis, you'll notice that it changes to these arrows pointing left and right. Now click and drag, and you can pull it in. And that's the end right there. Although that looks suspiciously flat on the end there. So I might redo the frequency thing again. But yeah, there's our bar graph, and it shows the frequency values. This would be the very first one in the list, and the next one in the list, and the next one, and so on. Notice they're all pretty high on the low frequencies, and then they get high again down here on the other end. This is what we call a frequency spectrum, and let's type that in. Over here is a text tool. It says ABC. I'm just going to click in the open space here. I'm going to type a title for this bar graph called frequency spectrum. Shows pretty much all the frequencies, all of the magnitudes at each frequency. So the x-axis really represents the frequency values, right? Because it goes up to 86, see, 86. And these heights really represent the length or the distance, the length of the radius, as I said earlier, or the distance from the origin at each frequency value, okay? Something tells me that's not right at the other end. Now, if I hit reset, everything should go away. That's not lost. It's just that I'm going to redo. I'm going to redo this. So let's go click this again one more time. as I click, it's interesting, it builds the graph at the bottom. And we'll go all the way to the end, just like we did before. Oh, it is flat there. Wonder why. And I think, see, as I keep typing the arrow key, it just builds flat lines. So something's not quite right. It really should end right here. So one more time. I think I just clicked the arrow key one too many times. And this is it's a really good graph because it does give you a whole different view of what's going on with your data. This project's really about data analysis as much as it is about, graphing a curve or reconstructing a curve. So at any rate, I think I hit it one too many times because of the flat line, but I'm not going to get overly concerned about that. Okay, so it gets the general picture of it. There's another concept here called the halfway point. It's called the Nyquist Frequency. So I'm going to type in Nyquist Frequency. It's good. It's a concept that relates to the frequency spectrum. What it does is it's the halfway point, and at that point, your positive frequencies, see the first half of the frequency set are really your positive frequencies, and then at the halfway, they're called the negative frequencies. And actually, what it's going to correspond to in the next video, you'll see the negative frequencies are going to correspond to rotations that are counterclockwise. So we have clockwise rotations. Well, actually, these will be counterclockwise, positive, and these would be counterclockwise for the positive and clockwise for the negative. So each radius has a different direction, basically, right? And cancel that. Where did it go? Did I type it? Maybe I need to do it again. Nyquist frequency. Yeah, cancel. Where is that? Well, it's the halfway. It's halfway between 0 and 86. Right. So 43.5. It's actually right between 42 and 44. So let's just draw an arrow to it. We can do an arrow like this. It's really not a vector, but the vector allows you to. Now I'll let you figure out exactly where that is, but it's roughly there, right? So in yours, depending on how long or how many numbers, how long n, capital N was, you're going to divide that by 2. That's your Nyquist frequency, okay? Okay, we'll stop this video here. We're going to keep these videos shorter day by day. So let me go and do that.